Welcome to the fourth section of this course, Introduction to Reinforcement Learning. This is a very exciting area of artificial intelligence today, so it's very important for you to know at least the basics. So let's begin. Let's see what we are going to learn in this section. In the first video, we will talk about some key concepts that are foundational to the reinforcement learning framework. Then in the second video, we will take a look at a simple environment so you can have a concrete example about the concepts we saw in the last video. In the third video, we will take a look at how to train a neural network for finding an optimal policy. And finally, in the last video, we will see how our intelligent agent will perform in the environment we will work with in this section. Okay, so this is the plan for this section. Let's begin. This is the first video of this section, Key Concepts in Reinforcement Learning. So in this video, we will talk about reinforcement learning and deep reinforcement learning, and we will present the main concepts in the reinforcement learning framework. So let's begin by talking about what is reinforcement learning. Let's begin by taking a look at the concept of reinforcement learning, which is an area of machine learning concerned with how software agents should take actions in an environment to reach some goal. Now, this goal is frequently in the form of maximizing some notion of reward. So, the reinforcement learning framework is very different from what we have been doing so far. We have been building systems that learn from data, but reinforcement learning is more like learning from interaction. So, in this framework, the software agent, as it's called, learns what to do so as to maximize a numerical reward signal. And the actions this agent takes are a function of the situation the agent observes. So this is the difference between machine learning that we have been doing so far and reinforcement learning, which is learning from interaction. Now, you may have heard of some headlines about these type of systems. For example, now we know that reinforcement learning systems can learn to play video games at a superhuman level, or that one of these systems was able to perform better in the game of Go than the world champion Lee Sedol. And this particular system, AlphaGo, was a special kind of reinforcement learning system. This was a deep reinforcement learning system, which is a combination of deep learning techniques plus traditional reinforcement learning techniques in theory. Okay, so this new field of deep reinforcement learning is the combination of these two subfields, deep learning and reinforcement learning. And some researchers even say that true artificial intelligence is actually the combination of these two subfields, the ability to learn from data and the ability to learn from interaction from an environment. Okay, so I have been using all of these words without defining them in the proper sense. So these are the definitions of the concepts we have been using so far. An agent is the part of the system that can make decisions, that is, take actions. And the actions are all the possible choices available to the agent. An environment is the part of the system the agent interacts with, and the state is information about that environment. Finally, a reward defines a goal in a reinforcement learning problem. So, on each time step, the environment sends the agent a single number called the reward. Now, we will take a look at a visual representation to see how all of these concepts fit and interact with each other. So here we have a typical reinforcement learning cycle. So we have a state and a reward, and the agent takes these as information, the state and the reward, and based on that performs an action. So interact with the environment with this action. Then the environment produces a new state and a new reward, and the cycle begins again. So this is the loop that we have in a classical reinforcement learning problem. Now, another very important concept in reinforcement learning is the concept of policy. And policy is the strategy that the agent employs to determine the next action based on the current state. So, in almost every reinforcement learning problem, the agent's sole objective is to maximize the total reward it receives over the long run. In this context, learning means to discover a policy to achieve this goal, to maximize the total reward that the agent gets over the long run. Not in the next step, not in the second step, but over the long run. Now, other very important concepts that we must keep in mind when working in reinforcement learning are the type of tasks that we can have. So a task is an instance of a reinforcement learning problem. We can have two types of tasks, episodic and continuous. Episodic tasks, which is, by the way, the example we will give in this section, is the case where there is a terminal state. For example, the game ending in the case that you are building a system that plays some game, or when a self-driving car gets to destination. Well, that's another example of an episodic task. So the system has a terminal state. Now, a continuous task, on the other hand, is when there is not a terminal state and the task, continues indefinitely, like a vacuum cleaner, for example, or a trading algorithm, or any other system where we don't have a definite end. Okay, finally, we can talk about another important aspect in reinforcement learning, which is one of the challenges that arises in this framework. And this is unique to this framework because here we have this trade-off between exploration and exploitation. Now, to obtain a lot of reward, a reinforcement learning agent must prefer action that it has tried in the past and found to be effective in producing good rewards, right? But to discover such actions, it has to try actions that it hasn't tried before. So that is exploration. It has to explore all the available actions to find the good ones. And when it finds the good ones, well, it must apply the good ones. But there is this balance that the agent must try to achieve, this trade-off between exploration and exploitation. And a good policy is a policy that can have a good trade-off between these two actions, exploration and exploitation.